welcome everyone to the seminar series. We're delighted to have Corbett Grainger present here today. So Corbett is an associate professor in agricultural and applied economics at the University of Wisconsin. And he's a fantastic environmental economist and resource economist as well. So we're delighted to have him here today. Corbett has worked a lot on distributional aspects of environmental policy, on property rights, and also on the political economy of environmental regulation. And so his work straddles pollution issues, marine resource conservation, and climate change. So we're delighted to hear your talk. I'll hand over to you now, we'll take questions at the end.
Awesome. Well, thank you very much, and thanks everybody for the invitation. It's great to be able to present during this lockdown. Let's go ahead and share my screen here. I hope that this works. Is everybody able to see this?
Looks good.
Okay, great.
Yeah.
So this is joint work with a former PhD student from Wisconsin, Ming-Xuan Fan. She's now at National University of Singapore. And what we're looking at is the impact of chronic air pollution on labor supply, and we're looking in China. This is a topic that's pretty timely, especially if you've been following the news and seeing kind of what a dramatic change in economic activity can do to pollution levels. The levels in China have dropped down to levels that they haven't seen in well over a decade. And so the question that we're asking here is basically how responsive are individuals to changes in pollution if they're determining how much they're going to work. So for a little bit of background, what we're looking at here is PM 2.5, and this is the probably the greatest pollutant of interest if you're looking at impacts on health and human-related outcomes. Just a little bit of background on why looking at China. If you look at the levels there, they're much higher than they would be in almost any other country in the world, perhaps save India, who's kind of recently taken over that honor, especially in Delhi. But if you look at the average population-weighted level in Chinese cities, it was about 61 micrograms per cubic meter in 2015, which is 3 times higher than the global population weighted mean, and about 6 times higher than the standard issued by the World Health Organization. And I should mention that World Health Organization standard is probably even a little bit too high, because most of the evidence is pointing to there not being really a safe threshold for PM 2.5. We're finding population effects, morbidity, mortality effects here in U.S. cities where the levels are much lower than the WHO standard. So the question that we're asking here is how does chronic air pollution affect an individual's labor supply? And I'm emphasizing chronic here because this is a little bit different than what other papers in this literature have done. And just to foreshadow what we find that it is pretty responsive. We find in the most conservative estimates that it's about unit elastic, so meaning a 10% increase in PM 2.5 levels leads to a 10% decrease in labor supplied by an individual. And then again, that's the most conservative estimate that we have. And so if you look at some of our others, such as two-stage least squares, it's nearly double that. So if you look at kind of pollution around the world, I'm just kind of emphasizing that China is a good place to look here. According to the WHO, the ambient air pollution in China has been something that we should really be concerned about. They did a global assessment of exposure and burden of disease, kind of a big sweeping study, kind of a meta-analysis of what we know about pollution in China. And this global burden of disease study found that ambient particulate matter in China is about the 4th ranking mortality risk factor in China. It contributed to about 1.1 million deaths each year, or about 12% of total deaths. And if you look at morbidity, it resulted in 1.2 million years lived with disability. So it's not just important for mortality, but it also has really important health effects. There's a big literature that looks at health effects, especially in economics. That's not what we're doing here. We're trying to focus on something different. And so the question, in everybody's mind is, what are the mechanisms? And given the data that we have, we're not able to say exactly what mechanism it is. We'll talk about a few hypotheses. The first is that pollution causes short-term illness and it worsens long-term health. And that's something that's been documented kind of over and over again in the literature and using better and better methods. Second is avoidance behavior, which I think is probably the most plausible that we have. It's either health or avoidance behavior. But there have been some studies in other locations, like in Latin America. Aragon et al. Had a recent paper, and what they argue was that the mechanism there was mostly caretaking for dependence, and the responsiveness that they found on the labor supply side was mostly through mothers choosing to take time off for taking care of dependents. So if you look at the literature on the impacts of particulate matter, most of what you find is both in epidemiology but also in environmental economics. It's big literature that shows kind of intense cardiovascular, respiratory diseases, impacts on elderly, impacts on infants. Infant mortality is always a big concern in persons with pre-existing conditions. And again, this literature is long. There's no way I can do it justice by citing everything. But what it suggests is that chronic exposure is also important. So most of the recent papers in economics look at really short-term fluctuations, right? They use instrumental variable strategies to find out what happens kind of within an individual if you get a spike in air pollution. But what we're going to be trying to study here is chronic exposure. And the thing that I think is worth mentioning is it's really difficult both in the epidemiology studies and in studies like this to separate chronic versus acute exposure, because the locations where you get these big spikes also tend to be places that are high in levels on average. So what we're going to be focusing on here is chronic. We're looking at long-term exposure, and previous papers have tended to focus on short-run shocks. So if you look in the economics literature and look at kind of impacts of air pollution on health, there's some great kind of meta studies, kind of literature reviews. Josh Graf-Ziven and Matt Nidell have a nice one in 2013, but of course there have been 7 years of studies since then, and lots of changes in exactly how bad we think this is. But fewer studies have looked at kind of economic outcomes. So we know that it's bad for health, and we're getting better and better at estimating that, especially with short-run fluctuations. But if we're talking about economic outcomes, it's a little bit murkier. So if you look at this literature early on, there were some kind of cross-sectional studies that looked at the association between air pollution and lost work days. And there are obvious reasons that we don't want to take that approach here. Right? If you're looking at a cross-section of cities or countries, and if you're looking at correlations between pollution and work days, you're going to probably find a positive association, because work days are what leads to pollution in the first place. So you're going to have a confounding relationship there. It's going to be hard to estimate that. And so what the recent literature in economics has done is focus more on labor productivity. And so we have a few citations here looking at hours worked. Paulina Oliva and Rima Hanna have a recent paper, and then Aragon et al. have another paper looking at hours worked. But the vast majority look at short-run fluctuations in air pollution and how that impacts productivity. And the reason that they do this is they're able to study kind of individuals in a workplace and hone in on jobs where it's really easy to measure productivity. And so Josh Graf-Ziven and Matt Nidell had their classic paper on pair packing productivity and pollution. And so what they look at was how many pairs can you pack in California per hour, and that's their measure of productivity. And then they look at within individuals shocks to pollution. And then there are a few that look at places like call centers or places where there are simple programming tasks given to individuals, something where you can measure productivity on a short-term basis and look to see how that fluctuates and changes in response to shocks and air pollution. But this does leave kind of a gap in the literature, and that's what our hope was as we started working on this. The existing studies are conducted kind of in a specific workplace. They tend to be focused in one place geographically, and so external validity becomes a concern. They tend to focus on short-term effects, and so at most we're looking over a couple of weeks in the previous literature and looking at fluctuations in pollution over those weeks. And again, few studies in developing countries, kind of in areas where we have extremely high exposure levels. So we do have some evidence that stock traders, for example, in New York City, tend to make more mistakes when the pollution spikes. And Matt Nidell has a paper where he's able to look at within individuals, so kind of holding individual characteristics fixed and look at shocks to ambient air pollution in New York to test that. And then he and Josh Graf-Sivan have that nice paper on pear packers. But again, these are kind of limited in scope because they're looking at one industry and short run effects. So this all just motivates the question that we're interested in here. We're looking at chronic PM 2.5 exposure. We're looking at annual averages in PM 2.5, and we're looking to see how that affects an individual's hours worked. I'll talk about exactly what enables us to do this.
Okay.
Yeah, so what we're looking at is labor hours, and we're looking at hours worked per week. This is self-reported, and we'll talk about potential challenges with that. But I do think that the potential challenges are outweighed by all of the benefits of using this data set. We were able to get restricted access to what's called the China Family Panel Studies, and if somebody's interested in talking about this later, I can describe exactly what this data set looks like. But this is a kind of like some of the labor studies, the longitudinal studies and the surveys that we see from the United States. And so they follow individual families over time. They go back, interview them over and over and over again, and we learn everything about all of the people within that household. And so we're able to look at the people who would be of working age and see how, kind of, again, within individual, they change their labor supply given changes in the pollution that they've been exposed to. The restricted access version buys us a lot because we're able to know exactly which sub-district these individuals live in, which is something that you don't get from the public use version of it. And so we were really fortunate that we were able to get this, because what we're able to do then is assign pollution to a household based on remote sensing estimates, which is something that's going to be really important. I'll explain in a moment why. So the survey follows about 16,000 households. It's more than 30,000 individuals. It's representative across China, so it covers 25 provinces. And we have the years 2010, 2012, and 2014. We're not able to, one thing I'll say is we're not able to go back and update for some reasons that I'm not going to discuss right now. But so the data that we have basically are the data that we're able to work with. In the analysis, we include individuals who are between 16 and 75. We play with that upper limit and the lower limit and some robustness checks. This just allows us to say these are people who would plausibly be working. And then there are some other variables that we have that we use, particularly demographic characteristics. We know their age, gender, education, marital status, if they have dependents, their self-rated health, which sector they work in. We know if they work in the same sub-district or if they work somewhere further away. And then one thing that I'm going to reference this later, so just to kind of footnote it now, the time of the interview is something that we have. Almost all of the individuals are interviewed between July and August, but there are some households that they had a hard time tracking down. And so they might have interviewed them later in the year, and that's something that we keep track of, because this is a backward-looking estimate of the number of hours worked, and you might expect that people who are hard to track down during those months might be for some reason different. Right. On the air pollution side, we're using annual average PM 2.5. This is a satellite-derived version. This comes from the von Donkler et al. 2016 data. This is an annual average of PM 2.5 at about a 0.01 degree resolution, and that corresponds to about a 1 square kilometer. So this is a pretty fine level of resolution. And the nice thing with this is we're able to take this, map it onto the subdistricts. Subdistricts are kind of like a census tract. They're pretty small areas within China. And so then we're able to get a really localized estimate of air pollution, which is something that you couldn't do for a lot of these individuals if we're using monitoring data. And that's something I'm going to talk about. So if you look at kind of annual averages for PM 2.5, we have a scale here. This is the 2014 wave from the von Donkler et al. Estimates. And so we do see some areas where you see hot spots coming up, above 100. And again, these are annual averages. These aren't peaks within the year. So an annual average of even 60, which is the population weighted average across China, keep in mind that that's 6 times higher than the World Health Organization standard. Now, there are some reasons to use the satellite data in this study versus monitoring data. I'm just going to explain this for a moment because I think it's worth spending a couple of moments on. So during the period that we're looking at, there were about 1,400 monitors scattered across the country, but the network was not established during the study period. And the monitoring of PM 2.5 going back to 2010, the first wave of our study, was not yet required. So if we're interested in PM 2.5, that by itself is one reason to use the remote sensing data. And again, that is the pollutant that studies are pointing to as being the most important for health and mortality. This map looks like it has decent coverage, but remember that China is a huge country, right? And so if we start zooming into areas, we'll see that the coverage is pretty sparse. So one concern about using monitoring data from China, this comes from a study by Ghanem and Zhang in 2014. They find a lot of evidence of manipulation of the monitoring data in China. And so what they find, if you look at this plot from their paper, on the horizontal axis, we have the annual PM10. It's PM10, not PM 2.5, but they're looking between 2001 and 2010. But what had happened was the government had set a threshold of 100 as the annual PM10 threshold, and it was difficult to get a raise or get promoted within the party if your city had particulate matter exceeding 100. And so what they find was that there was this kind of magical discontinuity that happened right around 100. And so what they're estimating here is kind of a kernel density, and they find something that's basically statistically impossible. They found a lot of misreporting in cities that would have been over 100 that were reporting something below 100. That's something that we saw back during this period when this was delivered kind of on a thumb drive. Basically, it was sent to the central authorities from the monitors and the monitoring authorities. But something similar has happened even when it was all reported online. There's been other ways to manipulate the data. So the validity of the monitoring data now is something that I would be concerned with if we were using monitoring data in China. And this is something that's kind of easy to establish. If you look at the data, this is a little bit difficult to see, but this is a picture taken by my co-author here. And what this is basically a water cannon where they're shooting water directly over the monitoring device. And the idea is if you blast that area with water, that brings the particulates out of the air, and so the monitor is going to be reading something like pretty pristine levels of particulate matter. And this is something that local authorities can do, is dispatch these water cannons on days that they're concerned that pollution levels are going to get them in trouble with the central government. Right? There are other ways to tamper with this, and these have made international news. This comes from the Telegraph, but there were officials that were stuffing cotton gauze into the air monitoring equipment to try to falsify the results. They were caught on camera doing that, and they were actually going back and splicing the film to put it on a loop during the times that they were doing it. And this isn't something that's just happened once or twice. This is something that's kind of widespread, and so we would have concerns just about the validity of the data. Another concern is the spatial distribution. And so, as I alluded to at the beginning, if you look at a map of China, it looks like they have decent coverage. But if you kind of zoom in within cities, here we have three of the largest cities. We have Beijing, Shanghai, and Chongqing. And if you look at the blue areas here, kind of outlines the boundaries of the city. And you see that there are a lot of areas, even within the city limits, where there's not really any coverage by the monitoring network. Right? And so even individuals who live in cities, it's likely going to be the case that if we're trying to assign a pollution level based on the closest monitor, that the closest monitor could be quite far away, and so it wouldn't give us an accurate representation of what pollution for that individual household looks like. Right? Keep in mind that this is for the biggest cities here. You can imagine that for the individuals that we have in rural areas, that it's going to be even worse. If you look at the satellite data versus the monitoring data and just kind of zoom in within a couple of cities, this is an example from Chongqing, the city referenced on the previous slide. In that city, there were 17 monitors in 6 of their districts. They had 32 districts that were unmonitored. And so on the right would give the histogram of what those monitors look like and kind of what levels of particulate matter that they would have. And then on the left-hand side gives the distribution that we have based on the individuals that live in that city in our sample. Right. And so if we had to be forced to kind of assign them to the closest monitor, it's unlikely that we'd be doing a good job. There's one thing to note here, that the levels of pollution that we're going to be measuring remotely are probably going to understate the actual levels of pollution. I'll come back to that in a moment. If you look at kind of across all of the data that we have for China, if we take the satellite data, which gives us an estimate of ground level particulate concentrations, what we find is that it does a pretty good job of predicting kind of fluctuations, and it does a good job of capturing monthly and annual trends. If you're interested in something like daily peaks, obviously you're going to have problems if you're trying to use satellite data. Part of it is whether or not you're getting a satellite going overhead at the moment that you're interested in, but also, there are going to be confounders like cloud coverage and other things. And what they find in this literature that does the comparison and kind of the validation of these data is that in places where pollution is really high, like in China or in India, that the satellite products will understate the actual pollution. And so what they say is that the values get saturated based on this aerosol optical depth measurement. And so if you just look at a raw correlation for the monitors and the satellite data that we have for 2015 and 2016, the correlation's about 0.77. So the correlation's there, but again, it doesn't pick up the dirtiest spikes as well as it would if we had universal monitoring on the ground. And then again, the reason that we're using the monitoring data is not just for the coverage, but also because pre-2012 PM 2.5 was not monitored widely in China. All right. So the next data source, we have the individual level data, and so this comes from the China Family Panel Survey. And so what we do is we're able to match the labor hours to pollution exposure for the previous year. Right. And so we have individuals who we can place in a sub-district, and the sub-district is basically like a census tract. And then using the survey month and year that they're surveyed, they're estimating the number of hours on average that they work per week for the previous year. We're then able to go and match their labor hours to the pollution exposure that would match that year. All right, so if you look at hours worked and particulate matter concentrations, On the left-hand side of the top here, so in panel A in the top left, that's the number of hours worked that individuals are reporting. And I'll mention that this has kind of a bell shape to it, and we see this big spike at 40. That's something that we'll address later. A lot of individuals report 40 hours over and over again, which could suggest that they have kind of a rigid work schedule. They're working the 40-hour work week and no more, no less. And so one of our robustness checks will throw those individuals out because it looks like they're not going to be responsive if they're always stating 40. But in the baseline specifications, we're going to include all of the individuals, even them. And then on the right-hand side in the top here, these are the changes in the number of hours worked. And so we do get some variation in the number of hours worked from one survey wave to the next, both in the positive and in the negative direction. And this is kind of centered around 0, like you'd probably expect. Okay. On the bottom two graphs here, on the left-hand side, that shows the annual average PM 2.5 levels for the surveyed population. This kind of shows the density in this histogram. And so we see some places that look relatively clean, some places that look really dirty. And then again, if you kind of take the population weighted mean, you'd end up in a range of 50 or 60, like we said at the beginning. And then on the right-hand side in panel D, what we have are changes in average PM 2.5 concentrations. And so these are changes within individual from one survey wave to the next. And what we see here is if you difference from one survey wave to the next at the individual level, we see some individuals that see an increase in pollution, some that see a decrease. And so kind of if you're thinking of the identification strategy here, since we're looking within individual, we're kind of looking at these changes in PM 2.5 and then how that affects the changes in hours worked. Right, so there are some challenges to identifying this effect. We'll kind of walk through these and then I'll explain how we're going to try to deal with them. The first is that you're probably going to have heterogeneous responses to air pollution. And so the easy fix for this, and again, the reason that we went with this data set and pursued it pretty aggressively is because with this data set, we're able to include individual fix effects over 3 waves of a survey. And so we can look within individual. Right, there's going to be endogeneity. That's probably something that some of you are wondering about already, why I haven't mentioned this. So there's going to be different sources of endogeneity, and so we'll tackle different concerns that you might have. One could be that there's unobserved factors that affect both pollution and the number of hours worked. This could just be macroeconomic conditions, for example, that affect both pollution and employment patterns. And the way that we try to deal with this first is using city by year fixed effects, kind of thinking that the individuals within a city year combination would be experiencing the same macroeconomic shock. And we push this a little bit further with some other combinations of fixed effects that I'll describe. There could be seasonal variation in weather and health that could create kind of spurious correlation between air pollution and labor supply. I mentioned at the beginning that some individuals are not interviewed during the same month because they weren't able to find them. And so they'd go back for the survey. And so what we include here are province by month fixed effects to capture these kind of seasonal variations that could vary over space. And then you could imagine that there could be sector-specific shocks, right? That some sectors could experience shocks that would be different. It could be construction if there's a big boom within a city, for example. And so what we include here are sector-by-year fixed effects, because if some sectors are experiencing a boom, or if some sectors are contracting, and if labor hours worked would be specifically affected for those workers in that sector in that year, then this type of fixed effect should be able to absorb those changes. So I'm going to highlight a couple of results pretty quickly, and then I'm just going to kind of get to the punchline here. If we look at labor force participation, basically we can include all individuals here who we see in multiple waves of the survey, all individuals who would be of working age. That's the top panel. And what we see, and as we move left to right, these are just different combinations of fixed effects. And so this preferred specification here is going to be number 4, where we have individual fixed effects, province by year fixed effects, and county by year fixed effects. But we don't find an impact of pollution on labor force participation or on unemployment. And so if you look in the bottom panel, again, the 4th is going to be the preferred specification because we have this combination of fixed effects that we want. We don't find an effect of pollution on unemployment. If you look in column 1 in panel B, we do see a small significant effect, but this effect, we're going to argue is not what we're trying to measure because we're not controlling for these other kind of systematic shocks that we could be worried about in sources of endogeneity. So in column 4, kind of our preferred specification, we don't find that pollution affects either labor force participation or unemployment, at least significantly. The effects are small and they're close to 0 as well as being insignificant. So the baseline model that we're going to look at when we're looking at the impact of pollution on hours worked. So the left-hand side, our dependent variable here is going to be hours worked, and we have a bunch of subscripts here, and these subscripts correspond to all of those combinations of fixed effects that I mentioned on the previous slide. And so our coefficient of interest is just going to be how does a change in pollution affect an individual's hours worked, and then with all of these fixed effects and then controlling for some of the time varying demographic variables that we have for these individuals. So in our baseline fixed effects model, so we have individual fixed effects and then province by month, county by year, sector by year fixed effects. Kind of across the board, what we find is a coefficient of close to -0.5. And so that means a 1 unit increase in PM 2.5 leads to about a 30-minute decrease in hours worked per week by an individual. Okay, and so if you think of how that corresponds to an average, that works out to be about unit elastic if you evaluate these at the mean. So again, basically a 10% increase in particulate matter leads to a 10% decrease in hours worked, holding all of these other effects constant. We have a boatload of robustness checks in the paper. I'm going to highlight a few of these. The first column here is just the baseline estimate that we have. This is the minus 0.48. So again, about a 30-minute decrease per week at the individual level. In the second column, we exclude those workers who are working fewer than 10 hours. So, think of them as working part-time. Our coefficient goes up a little bit, something greater than -1/2. Similarly, if we exclude individuals who report 40 hours per week in each survey wave, our coefficient gets larger. And then excluding extreme values for the number of hours worked. If you look at the descriptive statistics, there are some individuals who are reporting to work a number of hours per week that's mathematically impossible, right? And so we create different thresholds and go through and cut off the top end of these extreme values to see if it matters, and it increases our coefficient by about 10% or so in magnitude. There are some additional concerns that are worth mentioning. There could be within city by year sources of endogeneity. So think of traffic. You could have traffic that varies at one side of Beijing differently from the other side, and our fixed effects wouldn't be capturing that. And so one way that we can deal with the traffic concern is we can look at individuals who work in the same subdistrict that they live in, and so that's going to be one robustness check. Another is that the number of hours worked could vary slightly by the month of interview. We deal with that. There could be concerns about recall bias. The survey does go through and does some tests of memory and tests of cognition, and so that's something that we're gonna that we're able to test. And then there could be concerns about attrition or sorting. I'll mention that I'm not going to show the sorting results. Basically, there's a null result on the sorting. It's in, I think, Appendix C of our paper. But these other effects I'll walk through really briefly. So again, in column 1, we're comparing the baseline estimate that we had of about negative 0.5 on the effect of PM 2.5 on number of hours worked. The second column restricts the sample to individuals who live and work in the same subdistrict, right? And so that shrinks our sample by about 8,000 individuals. But what we do find is that the coefficient goes up quite a bit. And so if there is this concern about traffic and that the traffic impact or something similar to traffic, some within city by year variation that we're not capturing, then hopefully looking at this subsample that lives close to work would be able to capture that. And we actually find that the impact is quite a bit larger. It's not twice as big, but perhaps close. If you look at individuals that are interviewed in the summer, we find that the effect is slightly larger than just in the baseline sample. And similarly, if you look at individuals who have good memory based on the tests that they perform in each wave of the survey, again, you find that it's more responsive. And then this test for attrition basically suggests that there would be no impact on the baseline estimate. One final robustness check that we're gonna look at is perhaps there's measurement error in the PM 2.5 values. I mentioned at the beginning that it's likely that there is measurement error. We could be doing this two-stage least squares approach for kind of the classical concerns about endogeneity, but we're doing it with a two-stage least squares fixed effect model, so an IV fixed effects model, and so we are able to partial out a lot of the concerns that you may have about endogeneity. But what we do, we're trying to look for a plausible instrument that we could use during the study period, again, 2010 to 2014. And one thing that had changed was they started rolling out national ambient air quality standards for PM 2.5 and set it at 35 micrograms per cubic meter. And this had staged implementation. And so the first phase went after kind of the largest cities, which included provincial capitals, provincial level cities, which is a designation of cities in China, and then other major cities in certain regions. And then they had second and third phase cities where they were adding them over time, but they didn't come in until 2013 or 2014. So this was a staged approach. It wasn't random which cities were selected, which is why we're not completely going to hang our hat on this estimation. But this should address some of the concerns that we might have about endogeneity or measurement error in our PM 2.5 values, since these are remotely estimated. So the first stage here, we're just looking at pollution as a function of the National Ambient Air Quality Standards and all of our second stage regressors. And then the second stage, this equation 3, is just, again, the number of hours regressed on this fitted pollution value and adjusting the standard errors accordingly. Okay, I'm going to mention just briefly, we're not showing the first stage here just for time, but what we do find is that this was a good predictor in the first stage. The F statistics are on the order of over 100. And then if you look at the two-stage least squares estimates in columns 2 and columns 4, here we're finding that a 1 unit increase in PM 2.5 led to more than 1 hour decrease in labor hours at the individual level. And again, if you look to the bottom of this, we are able to include individual fixed effects, province by month fixed effects and province by year fixed effects in column 2. And then in column 4, we're able to have the individual fixed effects province by month, county fixed effects, and year fixed effects. We're not able to include exactly the same combination of fixed effects because of some collinearity that the instrument would have. So kind of right on time to wrap up and talk about how big these results are. So there are some previous studies that look and find short-term impacts on labor productivity, but not labor hours. We're the first that we're aware of that is trying to find an impact using within individual variation and pollution to look at chronic pollution. We find that chronic pollution doesn't just affect productivity. We find an impact on hours worked. Our most conservative estimate would suggest that a 1 unit increase in PM 2.5 reduces the hours worked by about 30 minutes per week. And then again, if you go to our two-stage least squares estimate, that would be more than an hour. Right? And then the other estimates are somewhere in between. We don't find any difference in the effect on individuals with or without dependents. We do go through this in the paper. But the reason for this, I think, is that the family structure in East Asia is very different from in Latin America. In Latin America, you'd expect that the mother would stay home if you had sick children or children who were prone to illness, concerns about pollution for your dependents. In East Asia, it would likely be the grandparents taking that role. And so I've always asked, how big are these effects? And this makes me a little bit nervous to say, right? Because what we're estimating here is in kind of a reduced form framework, either based on fixed effects and individual variation over time, or a two-stage least squares kind of fixed effects IV model. This isn't something that, we don't have a structural parameter here, and so extrapolating here is going to probably get me into trouble. But just thinking about how large these effects would be, if every individual had this responsiveness in China, then that would mean if you reduce PM concentrations across the board by just 1 unit, that's 24 more hours per person per year. But if you aggregate, that's huge, right? That's 17 billion more hours if you look at the working population of 1,715 million, right? And what this suggests is that if you took that further, and again, I'm not going to hang my hat on this because we don't have a structural parameter, but if you had a larger decrease in pollution, that you could expect that this could have a big effect on the number of hours worked. Obviously, there would be general equilibrium effects and other things happening there, so we won't go too much into those values. We do find a pretty large effect. Our effects are larger than the effects in the previous literature that look at hours worked. Again, those are based on short-run variation in pollution. Ours is based on changes in chronic levels. But this suggests that the economic impacts of pollution are much larger than just basing our estimates on morbidity and mortality, which is what most of the previous studies have suggested. So there could be important productivity as well as labor supply impacts of pollution. And I'm just 1 minute over. I'm going to stop there, and I'd gladly take any questions that you might have.
That was ace. Thank you very much, Corbett.
Sure.
Just to say, so Ian's raised his hand. I guess that means that he's got a question.
Okay.
So we'll hand over to Ian in a second. And for everyone else, if you could start putting your questions into the chat, that would be great. So Ian, do you want to ask a question?
I feel a bit embarrassed now. I don't. Okay, I'll do it while everybody else is thinking of better questions than mine. All right. So first of all, I want to thank you very much, Corbett, for an absolutely fab paper. Really enjoyed that. I loved the fact that you didn't just give us a load of econometrics. You also gave that fabulous intro to it, and even smattered it with some great comic insight into how. And it is interesting because I've been working with a US and Chinese team for a while on how do you incentivize city mayors and stuff like that, and it really is incredibly important.
Yeah, yeah.
That, and they will gain it absolutely. So you've got to get there ahead and gain it ahead of them. Just a general question about the results that you get. So I was, I wonder if you were, but I was a bit surprised by the unit elasticity. That seems pretty high to me. I was also surprised that given that, you didn't find a great difference in that result when you excluded the 40-hour group. Because the 40-hour group are the group that you might think, well, they have no control over what they do, you know, and they got to do it whether it's dreadful out there or not. So you would expect that if you take them out, that you get more sensitivity to it. And the results didn't seem to jump that much about it. So those two things. And one other aspect of that I was a bit surprised because I couldn't quite work out the story behind it, is that living and working in the same area had a comparatively big effect. And yet my intuition, and I may be wrong here, would be that if you live and work in the same area, then you're, if anything, less exposed because you don't have to travel, you know, and travel presumably is quite a big exposure thing. So how do you feel about your results, and is there more of a storyline behind it? Oh, and I've got one last thing. I edit ERE, and I'd really like to see this.
Oh, thanks.
To ERE because I think it'd be great. Anyway,
thank you. Those are great questions. I'm gonna do a kind of a cheap plug about incentivizing mayors because we have the same problem here in the States. A paper I've been working on that's under review. It's in the second round of submission, but we're finding evidence of it's not quite as blatant that we see in China with kind of changing the values or stuffing it with gauze, but we do find a lot of evidence that if you give too much local control to the individuals charged with siting the monitors, that they do avoid the hot spots. And so that's something that we're seeing in the States too. So I think a broader concern about using monitoring data as representative, I think in every context we should question whether that's true. So I was also surprised at the beginning by this close to unit elastic response that we found. The interesting thing, as you mentioned, is that it really just doesn't go away when we throw all sorts of things at it. If we compare our estimate to some of the short run estimates there's one from Mexico City and one from Lima, Peru. Those are the two other papers that I'm aware of that look at hours worked as an outcome variable. And they find that a 1 unit increase in particulates leads to roughly a 20-minute decrease in hours worked per week. But again, that's only over a couple of weeks that they're looking at. Again, they are able to look at the individual level, but again, they're in their study, it was driven mostly by maternal care of dependents. But they found an elasticity that was smaller, but we're also looking in quite a bit polluted area and over a longer term. So after I saw that, I wasn't quite sure what I would expect in terms of size. For the 40 hours concern, so we dropped them. If you remember this, there was a histogram where there were a lot of individuals who just always reported 40, but there are also a lot of individuals that just report 50 or just report 60, and so those individuals are still in there. So the effect of dropping the people who report 40, it increases our estimate by about 10% in magnitude, but it doesn't blow it up. And then for the individuals who live and work in the same area, I think there could be two things going on. There's one, so they don't have the commute that others would have, which could mean that they're less exposed during the commute. But the other part of that is we don't have the geocoded location for these individuals' workplaces. We do know if they work in the same subdistrict, but if they work in a different subdistrict, that's all we know. They don't report which. And so the individuals that are commuting further, we don't know what that commute looks like, and so we're stuck assigning the pollution based on their residence and not their workplace, or the kind of the longer term pollution that they'd see over the day during their commute. And so I think by dropping those other individuals, we might be getting rid of some of the measurement error and the pollution assignment too. So I think part of it's driven by this, by the realistic traffic concerns, because I know in some of these cities that the commute is getting really, really long, depending on which part of the city you work in. But I think that we're also eliminating some of the measurement error issues that we have in some of the other subsamples.
That's cool. All right, well, send it in.
Thank you very much.
All right, see you.
So yeah, I have a question, Corbett, on mechanisms. So I realized early on you highlighted that mechanisms are hard, but I was kind of curious. So you look at basically, is this a childcare issue that people are having to stay home and look after children, and you find seemingly pretty robust evidence that that's not the case. But I was just wondering whether or not you've looked at, because I saw that they have the self-reported health for the preceding year, I assume, in the survey. So I didn't know whether or not you can, if there's anything on that as a mechanism.
Yeah, so we looked at self-reported health, and it's that if you stratify by that and kind of do interactions to see if the effect is different, the coefficients are slightly different for those who have self-reported good health versus self-reported poor health, but we can't rule out that they're different based on the standard errors. And the difference in coefficients, it's not huge in the point estimates. And so I think it could be through health, but given the sample size and the power that we have, we're not able to pick that up. I think part of it is probably health driven, and I think part of it's probably averting behavior, but we're not able to get at that. We have another data set, a different survey where they do kind of self-reported health, but then they also go out and take vital statistics for individuals and do that over and over and over again. And one thing that we're finding in this other survey is that the self-reported health doesn't correlate that well with things like lung capacity. That some people will say, oh, I'm in great health, but you can see that their health is deteriorated from one period to the next, and that looks like it's correlated with pollution. So I think there are some problems with the self-reported health as an indicator. I think maybe they're too proud to say that they're unhealthy, or their knee-jerk reaction is, I'm not dead, so I'm healthy.
That's cheers. That makes sense. I see Jordan Suter has also got his hand up in the audience. Jordan.
Hey, Jordan.
Hey, Corbett. Great presentation. Thank you.
Thank you.
Hey, I have a question about knowledge that people have of air pollution and air quality. What sources are they using? Is it the monitoring data? Is it reported in the newspaper or something so that they could actually evaluate what the air quality is? And does that add an additional cost to inappropriate monitoring that may actually exacerbate these labor outcomes or health outcomes, I suppose?
That's a great question. And that's something that we've been looking at in another paper with some different co-authors, is exactly where do people get their information. I think that's important, not just for this, but also hedonic studies. If the nearest monitor is far away and you're getting your information from that, it's kind of a pretty noisy signal at best. During the time period for this study, I know that they were publishing kind of citywide estimates for pollution and putting out an air quality index. In the larger cities, that was almost always red because of the high levels of PM 2.5. but the kind of if you move forward now, there's a lot better information. You can get not just the nearest monitor, but you can use the Purple Air network in the United States, and that's penetrated pretty far in Europe as well. There are these kind of monitors that people can set up in their household that then gets broadcast to a network, and you can go on an app and pull this information down. But I'm doubtful that the median household would do that. I think at best they would take the news forecast, and I think you're right that if they're relying on kind of a news forecast or a news kind of report of what the average monitors are saying, that if we have an unrepresentative number that's coming from the monitors, either because they're placed in poor places or because they're doctoring the numbers directly, that would exacerbate the inefficiency that we're seeing. But where they get their information, I think, is changing in real time. I was in Vietnam in December, and I was doing a short course on causal inference in Saigon, and almost all of the students had an app on their phone that could tell them kind of what the real-time pollution reading was at the hotel where the course was being taught. But I'll take that with a grain of salt, because the students that were in there are pretty well informed, and I think pretty, they've, their concern about things like air pollution is probably not representative of what the rest of the population in Southeast Asia looks like. And my guess would be the same would be true for people in China.
So I think that we're now just run out of time. But thank you again, Corbett. That has been
thank you very much. Thanks for the opportunity.
Oh no, thank you. Yeah, thank you for accepting. Just so everyone knows, seminars coming up. We've got Thomas Sterner on Monday the 15th of June and Bridget Daly on Thursday the 16th of July. I think I posted links earlier to our website and our mailing list, but just in case you need those again, they're also in the chat. Thank you everyone for joining, and thanks again, Corbett.
Right, thank you. I'd welcome any questions or comments over email too. So if you have any thoughts, this is something that's still a work in progress, and we'd appreciate it.
Great. Sorry, I've just turned my mic back on. Sorry. I just wanted to thank you myself as well, Corbett. I really enjoyed that, and it was great that you kicked off this whole series with such a fabulous talk. I did just have one other little comment. Very partial analysis, of course, but have you ever thought about thinking about whether any of these changes might be cost beneficial? Because it's interesting that you are looking at something which actually isn't. It's not health, it's not utility, it's not well-being, but it is something that has a huge impact upon decision makers. They really care about this. I have seen lots of examples where a pound running through, a dollar running through the economy is considered far more important than a dollar of welfare. I think that's a fairly universal truth amongst decision makers. And I just wondered, clearly cleaning up air has a insubstantial cost. You're going to basically have to change your economy. And it's very interesting that right now we have this enormous natural experiment going on in the world where we've shown absolutely incontrovertibly that changing the economy has a huge impact on quality of air pollution, that sort of stuff. I just wonder if you would ever consider doing that sort of thing, because while really you should be doing it in a general equilibrium framework, and you could think about doing that, I still think it would be an interesting, almost back of the envelope thing to maybe even add on to a paper and just think, should politicians be doing anything about this?
Yeah. We've gone back and forth on this, and we have kind of tried the back of the envelope calculations that you're describing, and so far we've always been afraid to put it into the paper as it is, just because we don't have a structural parameter and we don't have a general equilibrium model where we can kind of have these economy-wide feedbacks. But I completely agree that whether or not it's cost beneficial is, I think that's the big question, right? We kind of motivate it by saying that this elasticity is something that politicians do care about, but I think the bigger question is kind of what are the welfare effects, right? But I'm just not. Yeah, I'm not sure that we have the right framework, but it is something that we talk a lot about. All right.
See you.
Thanks everyone.
Thanks very much, Corbett. Really fantastic.